Hello, guys. Good morning. Yeah, feel free to switch on your cameras now, and we don't have to start immediately. It's like 8:01, so let's give people a few minutes to catch up. Join in the meeting, and then we can start. Until then, you should just all feel free to talk amongst yourself or ask any questions you have. It's basically free-form conversation. Well, it could be technical conversation. You can ask me questions also. You can ask your fellow classmates questions also. But this is a time when you can feel free to. And I'm the only one with my camera on. So thank you, Thomas. We'll start at 8:05, okay? So we shouldn't be silent. Why is everybody so silent? Be talking. Ask your classmates questions, and see, ask them how they've been doing in their quests or coding, or even if you want to talk about some show you've been catching up on TV, that's fine too, because this is the casual talk part of class, okay? So you should just feel free to keep the airwaves occupied and talk while you're switching on your camera, okay? So I really do want as many people as possible to switch their cameras on. Just attending class without your camera, essentially, does not give me any information about whether the person is attentive or understanding material, as a consequence of which there is, you'll just not have an opportunity to get points for participation. Don't underestimate the value of participation points, okay? Because even if you do every other single thing, right? By the book and ace everything else, if you don't participate in class and on the Reddit, the maximum grade you can get is B+, right? You follow the if you follow that flow chart in the syllabus, you'll see, right? And then towards the end of the quarter, in the last few weeks, people email me saying, oh my gosh, my grade, is there anything I can do, right? So here's a standard question I get in email towards the end of the quarter: is there anything I can do to get my grade from B to A territory, because I've done everything else? I get this email a lot, okay? And the standard response I actually have to these questions, and usually I tell them, well, you have to try really, really, really hard, which is for the remaining 4 weeks or so. But the answer to that question is that, yes, there's absolutely something you can do to get beyond a B. But unfortunately, you had the chance for 8 weeks or 9 weeks and you missed it. And then you're saying, well, I didn't want to do all that work, but can I still get an A+? Right? That's like going to a shop or a restaurant and saying, I'm not going to pay you, but can you give me a meal anyway? Yes. So it's absolutely not going to work. And it is a habit you should pick up right away in A-level courses, because in B and C-level courses, it gets much more hard. It's far harder to get participation points without actually having the practice to participate. And having practice to participate, you should start right now, because it's starting to get your feet wet in group technical conversations, or even being interactive in class is much harder once you're in B or C, because there will already be other students who are vocal, and then if you're self-conscious, you'll feel 10 times more self-conscious, because there's all these other students who are doing cool stuff. Why am I not doing cool stuff? right? Strangely enough, right? Strangely enough, yesterday I got recommended a video on Facebook about a teaching technique, and there was this teacher who did an experiment in class. A very interesting experiment, okay? Very interesting experiment. So she took two, she divided the class into two groups, random groups, okay? So equal number of brilliant people. Everyone is brilliant, really, in my opinion, but they ran two random groups. And to one group, she gave three words that were jumbled up. And they have to figure out with the actual word, like a cat would be ACT, right? And the challenge is to figure out a word other than ACT, which is also possible from these letters. So both groups were given these letters. The only difference was that for group A, of the three words, the first two words were easy, like cat and bat, right? And the third word was hard, like America, right? Or jumbled up. This to the group B, the experiment was the third word is exactly the same, America, okay? Jumbled up in exactly the same way. But the first two words were impossible words, right? So no matter how you unjumble them, you're not going to get a pronounceable word, okay? So and she said, all right, go ahead, now decode the first word. Okay, and the B group, the B group tried very hard. Obviously, they can't find the answer because there's no word. But the A group said, yeah, okay, it's cat and act. Okay, done. All right, and then bat and tab, done. Okay, and then they saw this long word, America. Well, Canamary or something like that. And they said, yeah, that should be America, and they did that too. And group A, am I recording? Okay, yeah, I say it's recording. Okay, group A tried to figure out word A, right, and they failed. And I said, okay, time's up for word A. Now try word B, right? They tried to figure out word B, failed again, okay? Because obviously even the teacher would have failed, right? Because they couldn't do it. And then group C, America, exactly the same jumble. And group B tried and they couldn't get it, right? Whereas group A, got America too. Most of the people in group A got America too. So what is the conclusion? One conclusion you can draw from this. The conclusion is that in group A, the students, America was exactly the same, not more challenging, exactly the same letters jumbled up in the same way. But group A was able to decode it, but group B was not. And the only difference is that group A got primed by being given something they could do, and they did it. And so when they approached America, they said, yeah, okay, it's just another word, I can do it, right? Group B, they struggled with the first two words, and they said, well, there's no way I'm going to get a third word. And they gave up, okay? And that is the reason why group B did not get the long word. Group A did get the long word. So obviously, both groups have the same number of intelligent people. But in group B, the students just gave up, saying they can't do it. But in group A, they said, well, it's easy. That should also be easy. They did it, okay? So it is just a simple mindset change. Now, as the reason, and this is a total coincidence, isn't it? Yesterday, I think it was yesterday. Yeah, and I don't know if it was Facebook or YouTube, and one of those things, I got this video, and it was a very dull and drab video. It wasn't even colored, nice colors. It was dull, lots of background noise in a classroom. His teacher was filming it with a phone or something like that, maybe. So, chances are, most of the time, I might have skipped past that video, right? This time, it was a teacher trying an experiment. So, and it's 5 minutes long or something. Let me watch the video, and I saw it, and it was incredible. Right, and I thought I should tell you guys this story because it gives you in as incredibly objective a way, well, not totally objective, obviously, right? It's a very good way of demonstrating to students how the mindset makes a huge difference. Now, my claim is that you don't have to know any computer science. You could be a total noob. You could be a history, archaeology person who has absolutely never used computers, right? Maybe you're an archaeologist in the field and you've been out there in the wildies for 20 years of your time, so you don't even know how to use a computer. Okay, so even that person, if they start at 2A, my claim is that I can make them top-notch programmers by the time they finish 2C. Top-notch meaning you're out there and you can cut code with the best of them, okay? And there's obviously going to be topics that you don't know, which you will go on to master in grad school or other places. And in fact, when you complete 2C, solidly, you will be set up to learn those materials on your own, right? If you go to a college, high-paying college, you also just have extra help, right, to get you to the end. But if you, this is my claim, okay, and I think it's true. If you get through to the end, you will be in a position where you can actually Google stuff, find out what is the right, because sourcing material is the hardest in anything. So if you go to Google and type in how do you do binary search, you get a lot of links on YouTube. But figuring out which one it is, which one is most useful, because the way I did one time, I went to the STEM center. Okay, I went to the STEM center. Have you guys been to the STEM center on campus? Totally, you should go, right? So when I was on campus, during my first lecture, I would basically take all of the class, all of the students. I'll take them like a Pied Piper, right, into the STEM center, introduce them to Eric and all these other people in the STEM center, and have them code. So it's an incredible resource. You should go to the STEM center and take advantage of everything that's available there. Not just the food, but technology and help and all these things. Where was I going with that? Yeah. So if you start in 2A and just march through and get to 2C without giving up, because chances are most people who enter 2B and 2C without preparation, they'll drop, right? They'll find out very, very quickly, they'll find out they're out of the depth. After the first couple of assignments, they'll know, right? I'm just not cut out for 2B this quarter. I'll come back next quarter. In fact, I get email every quarter from students saying, hey, this is absolutely fantastic. I wish I, got more background. I'm going to come back to this course next quarter. Are you still teaching this? Okay. And I have I don't know, hundreds of emails like that. Not hundreds, okay, less than 100. A lot of emails from students saying, I'm not set up to do this class right now, but I want to come back and do it after I brush up on fundamentals, okay? So why do you want to put yourself in that situation where, you enroll in 2B or 2C and then say, well, I'm going to come back to this afterwards? So just master it. And when you're done with 2C, and after 2C, I'll even be happy to teach you some other stuff like web development, cloud, JavaScript, and how everything ties together to make an application, web app, like hugely massively scalable web app like YouTube or Google or Netflix. Massively scalable. You don't have to worry about anything at all. The system will take care of it, and it's out there. And I can show you how to put these things. Questing, for example, right? So I can show you how to do these things. So these are all not big projects, right? You can actually put these together in under a month. I can show you how to do these things, and it'll be great fun. And what I'm saying is that even if you didn't have any CS knowledge, if you just attend 2A and make up your mind at the beginning, saying, I'm going to make the center stage, you have to make it center stage, okay? If you make it center stage and you pick 2A with absolutely no backing in computer science, you don't even know what computers are, right? And by the end of 2C, you'll have such a solid backing that you'll be able to teach other people and get noobs on board, okay? And develop kick-ass stuff. Which you thought you would never be able to do. So I can help you. And you can come back and tell me if that's not the case, okay? And by the way, you should also feel free to reach out to Walter, set up times to talk. Walter, I hope that's okay with you. Where's Walter? I saw him a little while ago. There he is, okay? You should feel free to reach Walter via Reddit or email, I think, and say, hey, Walter, can we have a meeting, a one-on-one or something like that? Where you can explain this concept to us or me. It could be a group of people, and I'm pretty sure Walter will be happy. And he can just set up a Zoom session, and depending on you guys, you can have it, recorded and put it on the channel or not. It's up to you. But it would be good if you start reaching out to people, fellow classmates, Walter, me, STEM Center. Go to the STEM Center, take advantage of these incredible facilities. And the only reason I can think of why people are not taking advantage of all these incredible facilities that are available for free at Foothill, right? Food and STEM Center and tutoring and teaching, and this, you go to Wisant.com and look up how much it will cost you to get CS tutoring per hour, okay, from a good CS tutor. There's lots of students at Stanford who are trying to make money on the side, right? They make a lot of money just by tutoring students on Saturdays and Sundays and all, right? Because they want to go on a date or a party, and they want like a couple of $100 in their pocket, and they'll say, well, Saturday morning I'll tutor a couple of students and I'm set for the party on Saturday night. Yeah, okay, that's a couple of $100, and a lot of students do that. I know, right? Well, and in fact, I think my son tutored a student, and he made some money for And he was really surprised he got so much money. So you'll be able to do all those things. And so the reason why I think students are not able to take advantage of these, so the tutoring, you have to pay a lot of money. You go to Y Center right now and check how much it'll cost. It'll cost $100 per hour, okay? And you have to arrange for the tutor to come to the library or some common place, and you sit down and they'll explain it to you. And it's just 1 hour. After that, if you don't understand it, that's it, right? And it's $100. Whereas if you go to the STEM Center at Foothill, it's free. And you have qualified tutors like Walter and Lane and all these people who've actually completed all 9 questions in every color, right? Lane and all, he's aced too, right? So he's aced all of the questions. These are people who know what's going on. And so their input to you is worth a lot more than $100. It's worth a lot more, okay? Because, out there, a random tutor, you don't even know how good they are. And besides, they haven't done some of the challenging stuff in our class. I don't know if they've done it. So you're taking a chance. Maybe you luck out with a good tutor. Maybe you're not, but your $100 is, you forked it out already. It's gone, right? Whereas in STEM Center, it's not like that. So the reason, my theory, okay? My theory why many students are not taking advantage of tutors like Walter and Lane and STEM Center and food and things like that. And it's right, is because you're only paying $150, okay? This class, and many people are just dismissing it. It's just a community college class, it's $150. So yeah, well, I just have to do it and pick up the car, so it's not so because you're paying $150 only, a lot of students tend to devalue it, saying it's only worth $150. That is like total nonsense. Right? This course is not worth $150. I know my ex-colleagues at work, right, who are teaching the exact same material, or we're teaching anyway, right? So they're teaching the exact same material privately. They're not teachers, right? They're not professors. They're teaching the exact same material, all the stuff that I'm doing here in class, right? Starting from 2A all the way to complex algorithms in 2C. They're teaching that in 6 months, and they're charging people 6 figures. Okay, it's a boot camp. And eventually some of them gave up because they don't really need the money. They were actually doing this boot camp to identify good people. And so they were teaching this for a lot of money, and exactly the same, right? And so these courses are actually worth a lot of money, but students think it's only $150. It's not $150 because that's the part you see. You only see $150, but what the college gets and what I get is a huge amount, more than $150, right? I get a huge salary. The college gets a lot of money from the government for teaching these classes. So it's all subsidized. So if you want to put things in perspective, you want to look at this class as not a $150 class. It is actually the same value as a UC class or any other class. It's just that a lot of the money, the cost is being absorbed by taxpayers, right? And so if you look at it from that perspective, you're going to say, wow, I paid a lot of money. Let me go and get my money's worth before I go and party. Because, a party, well, it doesn't last. The memory of the party will stay in your mind for, a couple of days, couple of months. That's it, okay? But this will stick in your mind forever and ever. And so I think that is the reason why you should pay attention to when you're in college and all these things, especially not private colleges, right? Because if you go to Stanford or Harvard, people are usually painfully conscious of the amount of money they're paying, or their parents are paying, hopefully, right? Hopefully they know how much money they're paying, so they'll say, I need to get my money's worth. Whereas at a UC or a community college, you're still paying a lot of money, but the money is coming to us indirectly through taxpayers and your parents and all your well-wishers. They're paying tax, and that money's come to us. So students say, well, it's free, and so free is what free is worth, and they don't take advantage of it. So please do take advantage. Okay, I got an email from Foothill yesterday. Was it yesterday? Maybe the day before, from the dean saying, hey, please take your students to the STEM Center, right? And have introduced them to the STEM Center and do that. And I thought, wow, why am I getting this email? Because my students should already be in the STEM Center. I've been talking about the STEM Center to you guys from day one, okay? So please go, take advantage of these things, because all said and done, even though we have the money to run the STEM Center and provide goodies like, food and things like that for free, if nobody's going there to take it, then the department is going to say, well, we put these things out there and it's just being wasted, right? So we'll just cut back on these things and put the money somewhere else. So if you guys are not taking advantage of it, it's going away. Just like, if I don't have enough people enroll in my 2B and 2C, well, I'm not going to get assigned those 2B and 2C sections. I won't be teaching them, right? So I'll only be teaching whatever class I get assigned. There needs to be demand in order for the college to provide it. And if there is no demand, then we'll just scale down. And it is the management. It is a sensible management practice, isn't it? So you're providing services. This is being used, and that's not being used. Okay, so let's scale back and on what is given and not being used, and scale up what is less provided and being used. And so that kind of thing. So please do take advantage of these things, okay? And thank you for, most of you have switched on your cameras. That is absolutely fantastic. You can tell the difference. Go to our YouTube channel and look at the videos. The ones with all the photos, people will click on them, right? You have more views on them too. But if they're all just rectangles, nobody's going to click on them. And if you say something really clever and nice and interesting in those videos, that's all gone into the air, okay? And so please do make sure that you're interactive, and also your interactive is highly visible in class, okay? So that's what we'll do. So if you have any questions, you can ask me now. We'll go over those questions. Otherwise, if you have any issues, you can air those issues too, including Walter, okay? So he's a tutor, and he can also say, hey, I had some students ask me this question. Many of these students are asking the same question, so I'll go over this one, for 5 minutes. He could say that too, totally free. So it's open, right? For 5 minutes, let's say it is just an open floor, open mic, anyone can talk. And also use this opportunity to ask questions that we could address when we're coding, okay? And by the way, also decide who's going to code today, but at least 2 people, okay? It doesn't have to be 2 or more, but it'll be good if there's at least 2 people willing to code. It should not be who coded last class? Aldo. Where's Aldo? Aldo's not here. Where's Aldo? Oh, so I've only got one screen, and now it's not spilling over to the other screen. Okay, all right. So anyway, he's not going to code today. So not Aldo, someone else should pick up the screen at some point after you've asked your questions and everybody is happy with it, and we will start coding. And let's do something more interesting than last class. Last class, I think we just said hello and played with Endel and Newline, which I actually saw some interesting discussions about in the forums. Thank you all very much. Okay, so someone other than Aldo will take the screen today, and what we'll do is, let's say we ask, we'll start simple, okay? We'll start simple. The same program as last class is going to say hello. Let's say Alexis, for example, right? So hello, Alexis, how are you? But it'll also, before saying that, it'll ask a question saying, what is your name? Okay, and then you type in Alexis. And then it'll say, hello, Alexis, how are you? My name is so-and-so, okay? And you can pick a fictitious name. And I'll show you these things. And I'll also show you how to pick a random number, okay? I'll show you how to pick a totally random number because that is going to be the basis of lots and lots of cool things we'll do in class. Because, I kind of figured that once we have some kind of a game-like situation that we develop, and students tend to get a lot more engaged. So it was a fortunate discovery, I think. So since a couple of quarters ago, we decided rather than do these standard boring programs that, oh, here's a program, this is how you find a, greatest common divisor and, stuff like that. We decided to play with unpredictable stuff. Unpredictable stuff means we generate a random number, and based on the random number, we do some crazy things and interact with the user and turn it into a game. And every class, we develop something that is a game or a feature or some, visual effect. And students are actually looking forward to these things. And that usually is a lot more fun, I think. Okay, so we will do that. So anyone, hey, Alexis, are you still here? I didn't mean to scare you off, right? I'm not going to put you on the spot and say you're going to code today, so you don't have to disappear from class, okay? So I know she switched off her camera, but please stay in class, okay? So someone else can take the screen today. Do you guys have any questions? Any other questions that you want to ask me before we start doing some code? And then we'll also start changing that program. Ask for a name and say and greet the user, and then after that, get a random number and say and yeah, we'll do some. Well, I don't know. I get a random number is all I have managed to think up right now. But by the time we get to coding that, I'm pretty sure we'll have some good ideas of what we can do with the random number, right? Yeah, we'll get some interesting ideas what to do with the random. Okay, so we'll do those things. It'll be fun. And remember, okay, remember, even though you may not have coded at all, at the end of today, you will have a program that you can take and sit down with any random person, right? You go to KJ's Cafe, or Starbucks, or or your home, and go to your brother or sister or mom or dad and say, hey, I wrote this program, and it's it's interactive. Do you want to try it out? Right? If you do something, it's going to say something. Let's see what it says. Okay, it's going to be unpredictable to you and to them too. So it'll be a fun little thing. It'll be a real program that you have written that other people can run. Right? How cool is that? And you're doing that in this is week 2. This is week 2, isn't it? We started last week. Yeah. All right. Okay.
Yeah, it's week 2.
Hey, Nemo, and so I'm asking these questions. Many of the questions I ask is not with a view to getting an answer, because I already know the answer. Okay. So the questions I ask are basically an opportunity for you to exercise your vocal cords. Okay, and say, hey, say something, and so speak up. Okay, hands up and all. It's okay. Yeah, thank you for that. But it'll be nicer to hear your voice, because I hear that, when you speak, I hear a lot of you have very nice voices, right? It's not squeaky, and it's not, it's nice voices like singers. So you should all be talking, right? And you have beautiful faces. You should be showing your face and talking, okay? And so please do that. All right. So hey, David, do you have a question?
Yeah, one thing too is Alexa said she was grabbing her glasses. That's why she switched off her camera.
Oh, I see. Okay.
All right, cool. The second thing is I like reading the syllabus, and like you obviously mentioned it before, like it's a big no to ask what's wrong with your code and everything. But am I allowed to tell you the error that I got and ask like what it means?
Totally. Okay. Not me. You can just post it in the forum, right?
Okay.
You can ask everyone. You can actually take a screenshot. Just before you take a screenshot of the quest page, just look at it for a couple of seconds to make sure the password isn't there. Okay, because sometimes people get stuck after they get the password, because in many quests downstream, especially in B and C, in 2B and 2C, you'll get the password early on, but there'll be lots and lots of trophies after the password. So and some people get stuck afterwards, and then they post a screenshot saying, well, I get this error message, what's going on? But the password is right there for the next quest right there, right? So just be careful about that. But you can totally do that, okay? And also, even if you post a question with the code or giving away stuff, I'm not going to, you will never be penalized for that, okay? So you only get negative points for making mean posts on Reddit, where mean posts are the only thing that get negative points, okay? So even if you give away the answer, the only thing that will happen is I'll delete the post. Okay, I'll delete the post and I'll send you a private message saying, well, I had to do that because it gives it away. So feel free, totally free to, because I follow these posts every time, and I can delete every single post within a couple of seconds after you make it. Okay, because unless you make it, when I'm sleeping, at night, during the day, when you make a post, I get a notification within 10 seconds on, and I have my phone, even if I'm walking by the lake, I'll look at the phone, I'll say, what is this thing? And I can tell in a couple of seconds whether, there's a password there, or it's giving away too much information, or, there's a very slim likelihood that someone could answer your question and take away your lunch before you can eat it. So I can tell all of those just by looking at the question in 10 seconds. And so if there's a risk, I'll just delete it right there. And, I don't even remember who the question was asked by. So you're not even going to get penalized for those things. So please feel free to just ask away. The whole thing is meant to be interactive. Computer science, programming is not a solitary profession. Right? Yeah, even though technically you can sit down at home and do the simple things like that, you'll find that eventually to do some really cool stuff, it needs to be out there, and you will be interacting with other people, right? You'll be using their code, and you'll be asking them, hey, I want to do this in my code, but it's going to take me several hours to do that, but you've already done it. Can I borrow your code? And how many times? Yeah, maybe you haven't asked that already, but some of you are already programmers, I think, right, in other languages. So you probably already have that experience. You've gone looking for some Python libraries, okay? And it's a very rare Python libraries that are not out there, but you find someone who's actually done it, and you email them saying, hey, can I use that? So you'll do all these things. So you got to be out there. And this is a practice. This is practice. You have to take this opportunity to just be out there and so that when you actually enter the field, you're already marinated. You don't have to go there and just marinate first and then start being productive. You're already out there. You are an olive ready to be eaten, okay, when you go out there. And so that's CS2A. Sure. Any other questions? Otherwise, someone should just pick up the screen and then we'll start coding. Okay, and it's perfectly okay to start with an empty screen, empty browser, private browser. Just open up a private browser window, share the screen, and let's put it this way: the first person. Okay, Samir, great. Okay, and also I want to give this tip. Okay, I want to give this tip. Now I know that some of you already have experience programming. Okay, so I read the introductions and I see, like, even Aldo last class when we're coding, he was coding a little ahead, if you remember, right? He put the comment things and semicolon in place and things like that. My recommendation is that if you are already familiar with programming, resist the urge to take the screen until after week 6. Okay, after week 6 we'll be doing some really cool programs where you'll get the opportunity to sink your teeth more, because if you're already experienced, you're going to be writing simple programs, you won't be satisfied, right? And plus you've used up your chance, and then someone else will have to do. So that's just my tip, but that's okay, right? Nemo, great. So just Command A and delete. That's what we'll do every class. Okay, Command A and delete everything, and we'll start with a brand new. Oh, Samir, yeah, Samir. I said Nemo. Okay, great. So here's what we're going to do. At the beginning, we're just going to create our very standard template code, which is an empty main, which just does a return 0 and does not do anything. Now, I'm not going to do it, and Samir is also not going to type. I would like, thank you, Samir. I would like someone else other than Samir to basically call out the code. And it may be wrong, it may be, doesn't matter. We want it to be wrong, okay? We want it to be wrong so that, and the reason it has to be wrong is that when a wrong is corrected by you, that sticks in your mind much better than if you do the right thing off the bat. Okay, that's what I find in my experience, right? If I do something right and then, keep going on to the next one, and if I did something right, okay, well, it doesn't, maybe it's by chance and it doesn't stick in my mind, but if I do something wrong, and then figure out it's not right and I have to fix it, that's it. That's the very last time you've made that mistake. That's why it's very important to make as many mistakes as possible in your life. Now, as many non-fatal mistakes as possible, you got to do in your life early on, so that later on, you can recognize these mistakes before you get to them, but not after you're sunk. And so that is the reason. Okay. All right. So how about someone else? And we're all going to be filling in. Okay. So how about someone else? Call out what Samir is going to type. Like, I can tell you the very first thing is going to be, and you don't have to do it in sequence. Okay, the first thing is you could just do int main like we did before, fill it out, and then later on you can put the include files and all these other things. Okay, so can someone please go ahead and tell what needs to go inside of main? Okay, so someone tell me, Samir, what needs to go inside of main right there. Right, we did this last class, right? It doesn't matter if you don't remember. I'm pretty sure Samir is going to type it in a few minutes or a few seconds. But if you do, if someone else,
do you need to include the input output stream? Or
yes, we absolutely do, right? And who said that, by the way?
That was David.
Yeah, David, thank you. Yes, we absolutely do. And the reason I didn't start off by doing that is because it's just to give you a feel for the kind of nonlinear development. Because as you get experience, you're not going to do things in sequence. You'll just do this and like that. Yes. Okay. So you can get used to that right away. You do this and then say, before I run it, I need to put that there. Okay. And because that's what you'll do later on. When you have to, we're coding something and you can ask Walter, you're coding something and you say, well, you know what, here I need a vector. So let me use a vector. But in order to use a vector, I need to include the vector include file. But, let me finish this first and then go and include vector. So you're going to be doing that millions of times. So that's the reason. Okay. So someone said hash include IO stream. I think David said that and Samir inserted that. Okay. Now this itself, if you stick in a return, I don't know. Someone, go ahead. Complete it. This program should not do anything. It's just, when it's called, it should just return, and then we'll take it from there. Okay. Well, Samir completed it, but technically, that's what someone would have said. Yes. return 0. It's okay, Samir. We'll have lots of opportunities for these things. Okay, now, and the first thing you want to do is run it and see if it works.
Yeah.
Hash include.
You misspelled include.
Oh yeah, include. I strangely enough, I do that. INC, INLC, I do I don't know. It's not even next to each other, but I do that too. So it's funny. All right. Okay, good. So yeah, there you go. Finished with exit code 0. Is everybody happy so far? Okay, that's your basic program. You've already got a C++ program that works. Okay, so if that is your program, that is your nothing, right? It's a program that does nothing at all. So that is your nothing. Once you can make nothing, you can make everything. That's what I say. Right. So now what we want to do is essentially the first step is let's put a comment in there. Yeah, that should go. Yeah, okay. Well, that's not the comment I had in mind, but let's put the comment about what we're going to do. So we'll put a comment on the next line saying we will ask the user to enter their first name. Okay, so we'll put a comment there saying we will ask the user to enter their first name and read it in. Right, we ask the user.
And then what?
First ask user the first name. And greet them. And read it in. Read it in. Okay, so that's all we're going to do. It's very, very simple. Okay, so it's just 2 steps and it'll be very easy. You have to do it a few times, right? After class, without looking at the video, write this exact same program, try to reproduce a program without looking at it, and get it to run just like what Samir is doing. Do it 3 times. Okay, 3 times from scratch without looking at it. And if you can do it, and the first time you do it and you get stuck and you got to look at the video and say, okay, that's what you got to do. Second time, you're going to do it again. You get stuck at a later point. Okay, you look at the video and fix it up. Third time, you'll just do it all the way without having to look at the video. Yeah, just like you're practicing an instrument, right? You get stuck at a different note, but this note you get stuck at is later and later in the measure. So, all right, so so that's what we're going to do. Now, the first thing when we, what are we saying there? Ask the user, okay? So we're gonna ask the user. How do you ask the user? Okay, not Samir, not me, someone else chime in and say what Samir should do there to ask the user, meaning he's got to tell the user something. What does he have to do?
You put C in and then right shift. And then, yeah. Wait, no, pardon me. You declare a variable and then you put that in.
We have to, hey, Nemo, we have to ask the user first before you see him, before you get into the content. We have to ask. Yeah, so go ahead and ask the user. You can say, what is your name or something like that. Great. Okay, now, so there's a few things I want to point out here. Does anybody want to take a crack at fixing that, or do you want me to do that? Okay. There you go. Okay. All right. So Samir fixed that up. So it is C out. When you send stuff to the user, it is C out. When you read stuff from the user, it is C in. So it's the thing is flipped around. So that way is out and this way is in. And so we are the thing. Okay, standard C out. Now, this is an aesthetic thing. Okay, and you don't have to follow it, but this is how I do it. And so we'll do it that way, just so you know. So whenever you and doing it this way, you'll now understand what that the difference between endl, and /n, which you guys have been talking about endlessly on the forum. You'll actually see that in action right now. So, and it's because of the aesthetics. Now, what I do.
Yes, I'm so sorry. I completely forgot to.
It's okay. I was just wondering if I don't know if you want to cut off that too.
Sure. Yeah.
Are you going on lunch or?
Yeah, I won't be on lunch.
David,
same thing.
you
I get back to
gotta mute.
I get to you at 9:30.
9:30.
Hey, I'm sorry. Am I interrupting a conversation you guys are having?
Yeah. I'll text you again.
I think my teachers.
Oh, it's David is talking to someone, is it? Well, I thought Samir was talking. I thought people were talking to Samir. I'm so sorry. Okay, David was talking to someone else. Okay, all right. Now, so the aesthetic reason I'm talking about, the aesthetic point I'm talking about is that when we ask the user something and they need to give us input back to us, I prefer for the question to be on the same line as the user's. So what is your name? And then Samir types SAMIR. I prefer that he types SAMIR on the same line as the question because it looks nice. Because, you know, prompt, and then you type it right there on the right side of the prompt. If you have an endl there, what it's going to do is it's going to say, what is your name? And then it's going to ask for you to type it in on the next blank line. And you can try them both out and you'll see which one is better. I prefer the way when you type out the prompt and then you ask the name right there, which means that we shouldn't put an endl there. Okay, so get rid of the endl and just put get rid of the endl and put a semicolon, right? Put a semicolon right there. So that means now it's just printed the and remember, this is not going to work, okay? And it's not going to work for a very interesting reason that you will immediately put your finger on. I can tell, I guarantee it's going to be real fun. Okay, so so you've asked the question. Now you're going to read it in. Now you can say cin standard colon cin. Cn. Now you're going to say right shift instead of left shift. It's a right shift. It's coming into us, not right. Is that right shift? Yeah, it's a right shift. Now, what the user types in has to be taken and stored somewhere. Yes, because if they, if they give it to us and we don't store it anywhere, it's gone, isn't it? So we got to take what the user said, told us in response to our question, and we have to store it somewhere. So where do we store it? What is the user going to type? Is the user going to type a number or a string or something else? When you ask a user, what is your name? Are they going to type in some characters, A, B, C, D, or are they going to type in a number?
String.
String, yes. So a string is basically a string of characters, a string, right? Characters. So what we want is a string variable. A variable is a box into which you can put different values. You can take the value out, put a different value in, okay? It can change values, variable, same like in math. So we need a variable that is of type string. So we're going to tell the compiler, even before we read in what the user says, we're going to tell the compiler, the C++ compiler, hey, in this program, I'm going to ask the user to give me something, and they're going to give me something that I'm going to put in a string box. So give me a string box, give me a string variable, which I can use to take the user's input and put it in. Okay, so let's go right to the top of main, immediately after the curly brace, and hit enter. Right, we're going to tell the compiler, I want a string. So you say std double colon string, std double colon, it's a standard string, okay? Std double colon string space, right? User underscore name, user underscore name. That is a name I've given to the variable. You can call it whatever you want, okay? You can call it X, Y, Z, but usually it makes more sense to call the name, something that makes sense. So we're calling it username. Now put a return there, enter. And it's good practice, aesthetic practice, to have, that is called a declaration line. Declaration is where you tell the compiler, this is all the stuff that I want, okay? And the logic is this is all the stuff I'm going to do with the stuff that I've got. Now, most programmers you'll find will put a blank line between the declaration part and the logic part. And in fact, as you get more experienced, even your logic will be not so simple anymore, right? Your logic itself will be broken down into chunks. And you'll find experienced programmers say, even in the program, I'm going to put blank lines here, 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 because that's one part of the logic that's self-contained. That's another part of the logic that's self-contained. Right? And this is just like paragraphs in English. If you're writing an essay in English, you write the whole essay in one page, right? Without any line breaks. What is the teacher going to do? She's going to give it back to you. I say, oh, take it back, organize it better and give it to me. I've had that happen to me many times when I was in school, right? So it's exactly the same in programming. So you have to use the white space. It's called white space, blank lines, empty spaces. They have to be used judiciously and wisely. And that only comes with experience. Just like you have to read lots of books to get a intuitive feel for where people are breaking paragraphs, where people are putting spaces, where people are using exclamation marks, question marks, all of those things, stylistic issues. Well, because that's why, writers read a lot, or they have read a lot early in their life. Because after you read a lot, you get a feel for how to write. Just like that, when you read a lot of programs, you'll also find out right? Where should I do these things so that the aesthetics of my code are now such that a professional could look at my code and read it without having to put in extra effort. Now, what happens actually out there is that, people have different levels of skill. Total professional reading someone else's another total professional's code, they can read through it like that. Okay, because they know they can relate to it, and only the right parts of the code will be there. But most of the time there are different skill levels, and so this program can be read at the same speed, right? So it's maybe this beginner level comments, or maybe some structures need to be decoded. Why are they doing it like this? It's less efficient. And then these thought processes take time, so it takes longer time to read. And so, but by following code and reading other people's code, you get a very good sense of saying, this is how I structure the code so that someone else can read my code really, really easily, as long as
I have a question. Is this an identifier for something from this specific, I don't know what you would call this, like, is this a package, or basically, like, is this basically saying, this statement is saying that bring string, and string is a concept that comes from here? And if I include this, do I still need to include the std identifier? Would it be
good question? Thank you so much for asking that, Samir. Okay, so what Samir is asking, there's two things here. What is IOStream? Is that a variable, or is it a package that we include? Okay, that's one thing. And he's also asking, now that I include the package, what do I still need to put that standard colon everywhere? Okay, and it is a total pain. I totally agree with you that inserting the std double colon is called a namespace qualifier. We won't talk about that now. Namespace basically says I have lots of variables, and I have 5 million variables in my program, but it becomes very disorganized very quickly. So what I'm going to do, the same thing I'm doing with my program itself, I'm going to take all my variables and group them, right? This bunch of variables belongs to something, right? This bunch of variables is to do with vector manipulation. This bunch of variables is to do with this. So let me all put these variables in different buckets, and I'll give them tags, so that the same variable name can be used in different places, except they've got different tags, so the compiler will think they're different. So it's called a namespace. A variable lives inside a namespace, and only within that namespace it can be known without that extension. If you go outside the namespace, you got to say, I want something called cout, but that cout comes from something called the standard namespace. So you put the std double colon. If you don't want to do that, which is what many of us do, right? Go above main, one line above main. Yeah, right where you have the comment. No, where you have that comment there. Yeah, there you can say using space, namespace space, namespace space, std semicolon. Okay, semicolon, and hit enter. Okay, now when you say that, the compiler from that point onwards, if it encounters a variable that it doesn't know, it'll look in that space and say, well, I don't know, this is Samir is using a variable called cout, but there's no cout in this program. But however, that person is using a namespace called standard. So let me see if this std double colon cout exists, and it'll find it, because std double colon works, right? Now, once he's done that, you can get rid of the standard qualification on your variable names, and it'll still work on your variable names, right? So you can get rid of that. So it just saves typing. The one thing to remember is that, we haven't talked about include files. So the good practice is not to put that statement using namespace standard in include files. You should only put that in source files. The reason is because lots of people will include files, and I suppose they don't want to have that in, so we'll come across those things. Now, what is that IOStream? Where is it? Now, this is a Mac, isn't it? Hey, Samir, this is a Mac, isn't it? Yeah, it is a Mac. So I can show you what that IOStream. IOStream is actually a file. It is a file, just like the program that Samir is writing. IOStream is also a file. It lives somewhere in the system directory, some folder in the system. There's a file called IOStream. I can show you where it is. If you momentarily switch to a terminal, right? Samir, if you open up a terminal on your Mac and share the terminal, in fact, you don't even have to go to a terminal. Let's try this. Go to open another tab. and go to cpp.sh for a sec, cpp.sh, because it gives you a free Linux terminal, right? I think it does give you a free Linux terminal. Now, where it says execution, the 3 tabs below where it says execution, below the 3 tabs, yeah, click that execution part. What about compilation? Oh, hit run for a sec, hit run. Okay, now where's it runs? Okay, well, let's go to there's another site which gives you a terminal, or just go to your Mac terminal. I'll show you in a Mac terminal. And I think I'll show you something really cool too. Can you hit Command plus a couple of times so that the window is bigger? And you can actually make it full screen too. And Command L, Control L to clear the screen. Control L to clear the screen. Hit Control L. Okay, now Command plus a few times so that I can see the font. I can't see the font, by the way. It's a few more times actually. Yeah, I think that's good. Now hit Control L. Let's take it right to the top. Yeah, that's good. Hit Control L and it'll go to the top. Right. So IO stream is a file that lives somewhere. So if you do, I'm going to try this. It may not work on your machine depending on what you've installed. Type in locate LOCATE space iostream.h, or just iostream maybe. Locate database. Oh, it does not exist. Okay, I think where it exists is try this. Okay, type less less space / USR US user, right? USR I think include INCLUDE and then hit tab a couple of times. Tab a couple of times.
Nothing comes up.
Oh, you did hit tab?
Yeah.
Nothing happening?
No, nothing's happening.
Nothing's happening. INCLUDE. Hit Control D. No. User include and then hit Control D. What shell are you using? Or maybe I don't know. Okay, I'll show it to you later. Okay, it is a file. It's a file that lives on this machine. Oh, in fact, just go to Google and find out. Just go to Google. Just go to your browser and just go to Google. We'll see iostream.h. Okay, just type in iostream.h and it'll show you the contents of the file. Hey, by the way, Samir, is this a private window or not?
No.
Yeah, just make sure, maybe it's you didn't expose anything risky, but just make sure that you use a private window later on anyway. Because when you open a new tab, you see all those bookmarks that you get, visual bookmarks. Maybe that's your driver license or something like that. So you don't risk these things.
Okay.
So iostream header file. No, then go back. No, not this one, the previous one. All right. You'll actually see iostream.h. There is a file. You'll find a link that shows you iostream.h. Yeah, full file. There you go. Right, and it'll show you the contents of those files. There you go. Source file. So that file, that is a file. That is the file. When you say hash include that file is basically just included, bam, like that into your program. So even though you write a program that only has 3 lines in there, when you say hash include, the compiler does not see your 3-line program. What the compiler sees is actually how long is this file? Go to the very end. It's like 9,000 lines, is it? Or 900 lines, right at the bottom. 960?
Just
no,
says
how
60.
many? Oh, wow, 2060? Wow, that's a lot of lines. Okay, so all of those lines will get included into your file. So the compiler does not see your 3-line program. The compiler sees a 2063-line program. Or whatever, this entire thing. And I can show it to you. If you want, I can show it to you. So now if Samir goes to the terminal, I can show you what you actually get from that file. Okay, go. Hey, Samir, go to the terminal. I'll show you something really cool. Okay. Oh, you closed it. So you got to, do that. Now, what we're going to do is, maybe you don't get these opportunities in other classes, but this is going to be fun. Okay. I'm going to show you what actually happens when you compile a program in the back end. Okay. So we're going to change folders. Now, right, we're going to change folder and go into a temporary folder, which will be deleted. So you can create junk there and the system will clear it out. So you don't have to clean it up later. So cd space /tmp. So tmp is a directory, a folder on your Mac, on your computer, where you can just go and create stuff and forget about it. Okay. So yeah, enter. Now, if you want to see what's in that directory, you got to type in a Unix command saying ls space -l No, dash. Before you hit enter, well, I don't think you'll have any private stuff in there. Hit enter. Okay, so these are all files that already exist in that directory, and most of these files were created by the system. So they have these funky names, and the system also uses the temp directory to store temporary stuff and then clears it out. So we're going to create something here and compile it and also see what's going on. Okay, so let's now create a file in this directory. So if you go to your Chrome browser where you had that your code, okay, copy the whole thing, your code, yeah, Command A and copy, copy, and go to your terminal now. Oh, we didn't complete the program. Well, you got a C in there, and let's complete it and then go there. Okay, so we'll just complete this and then go there. Okay, so now we're gonna say cn into username. Okay, cn into right shift into username, semicolon, and then on the next line you're going to say cout, and you say hello, hello space, and then and then username. Now the way that Samir has typed it has got a very common issue that beginners will face, which I'm not going to, you'll see it when we run it. Okay, and once you've seen it, you won't do this again. Okay, username and then do an endl. Okay, now one of the things we need to do is you have that /n after what is your name. Get rid of that. You don't need /n, because we said that we want to accept input on the same line as a user. Yeah. Shall we do it both ways? We'll do it both ways. But put the /n. I'm sorry, Samir. Put the /n and then we'll go back and remove it and do it one more time. Okay. Now run it. Okay. So he's going to type in his name and says hello, Samir. Okay. So far it works. Yes. Now, what I suggested before was let's do it a slightly more aesthetically pleasing way. So aesthetically pleasing, meaning I don't want, Samir shouldn't type in his name on the next line, should type it on the same line as what is your name and type it right there. So in order to do that, you want to get rid of the /n. Now, if you run it, you'll see that it actually doesn't do what you want to do, right? So, oh, does it? All right, it's not supposed to. Technically, it is not supposed to do that, I think, because well, it does that, but because we didn't have an endl, what usually happens is that it will not flush it. What is your name is still sitting in the buffer. You won't see the prompt because there's no endl. If you have a /n, it'll flush it. But if you don't have a /n or an endl, it's not going to flush it. It's going to be there. You won't see. So Samir will have to type it in when the system is waiting for him to type it in, but it hasn't printed a prompt. Yeah, but I think what happened here is that because there's a cn accepting user input, the system figured out because of heuristics saying, well, now it's time for the user to type something
in. Could you explain that again?
So the expected behavior, or my incorrectly expected behavior, was that when Samir ran this program, there is no endl at the end of that line. Yes or no? The first cout, there's no endl. And there's no /n either.
Excuse me, sir.
Sadvik, yes, go ahead.
Could you explain that again? I didn't get it.
Yeah, that's what I'm doing. Sadvik,
okay.
You can switch on your camera because I don't know if you're, so that's what I'm going to do now. Okay, so I'm explaining what's going on. Now, what I expected to happen was that because Samir didn't put a /n or an endl, that what is your name string, which was sent to the console, will not appear on the console. It is just sitting in the buffer until it gets a flush signal from the program saying, well, you know what, /n, flush it, or endl, flush it. Until that, the user will not see that. And yet you're reading from the user, which means even though you've not asked a question, you're expecting them to type something in, which you're reading. So that results in a crummy user interface because you're asking the user to type something in without asking them to type something in. Yes? Sadvik, yes or no?
No, sir, I didn't get it.
So when you don't have a /n or an endl, by the way, Sadvik is the only person who said, I don't get it, but I am 100% sure that he's not the only person. Okay, there are other people in class who also didn't understand it, and obviously a few of us do understand it. but some don't understand it. So please feel free. He should not be the only one who's taking the brunt for everybody else. Okay, so everybody should feel free to say, well, you know what? Everybody wants to ask questions. So I'm going to go over this one more time. So tell me if this makes sense or not. Okay, and hopefully someone other than Sadvik, and also Sadvik because he didn't understand. The function of /n and endl, which you guys have discussed in the Reddit forum, is basically to say whatever is in the buffer waiting to go to the console, waiting to go to the screen, send it. That's what the endl actually does. Yes or no so far?
Okay, yeah, I get it.
Okay,
So
good. Now, what Samir has got on line 14, is it line 14? Yeah, line 14, no endl at the end, but he still sends something to the console. Yes?
Yeah.
Okay. Now, when the system executes that line, is the user going to see what's your name on screen or not?
No.
I think not, because there was no endl.
Yes. No. Yes. The user will not see the line. However, even though the user has not seen the line, we're asking the user to type something in. How does the user? So there's going to be a blank line, and the user has to type the name in. So we've got to
Okay,
see
yeah,
in.
I get it. Yeah, I get it now. Yeah.
You get it now? Okay. Now that is the expected behavior. However, that didn't happen. So when Samir ran it, it actually did print, what is your name? Even though on the same line, no endls, no /n, but did print it. So it flushed the stream, even though there was no explicit flush. So that is a very subtle point. And so are we together so far? Even though we didn't tell it to flush,
Yes,
it still flushed it. Yes or no? Go ahead, guys.
So does that insinuate that cin has some sort of flush function as a result of it coming after like another console out?
Great. Yeah, exactly, Samir. So what Samir said is that even though we didn't flush it, we have a statement following it, which is sending a signal to the system saying, well, even though they didn't explicitly flush it, something is happening here, which expects a flush to have happened. So go ahead and flush. So internally, the library has some clever heuristics built in. That's why endl is not the only thing that flushes it. /n also flushes it. Okay, /n also flushes a stream. So endl is not the only thing that flushes it. You use endl if you want an explicit flush, but even if you don't use an explicit flush, the system has some, AI, some heuristics built in saying that certain other things also flush. So /n is one of those things. One other thing is that even if there's no endl, no /n, but if the user is trying to read from the keyboard, that is another signal to the system saying anything in the buffer, flush it. Because, we're trying to read from the user, which means that everything we need to tell the user, give it to them right now, because we're asking them to say something to us. Yes, does that make sense?
You said that /n also flushes. But it, like in another example, if you were to like have like cout and then just copy this and then this without the cin.
Do it. Try it. Why don't you try it? In fact, what we should do is, go into your code. I'll show you how to try that in a nice way. Okay, get rid of the cin. Now, no, this will happen immediately, right? You have an endl at the end, so it'll get flushed. What we want is for it to sleep for 5 seconds and then print it, so that so after the comment line, get to the next line and say sleep, 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 and within parentheses you say 5. 5 seconds, right? And in order to use that function, semicolon at the end, semicolon. Now, in order to use the system function called sleep, we got to go right to the top of the file and write hash include. You got to include a file called unistd. I don't know what it is, Unix standard or something like that, right? And by the way, I don't think you need the hash include string, right? Hash include string is already included from one of the other include files. So I was to get rid of the hash include string. Let's see if it works. Okay, without it. Okay, now if you try this now, hello. Oh, I see. Now what you need to do is now take that cin username. You have the cin statement, right? Uncomment it and put it after the sleep. Uncomment the statement and put it after the sleep. That is a perfect experiment. Perfect experiment for us to run. Okay, put it after the sleep, not before the sleep, after. Okay, great. Okay, now this gives you the answer to the exact question that Samir asked, and probably will clarify a lot of things for Sadhvik too. Because what's going to do now is it's going to send what is your name, and what is your name is not going to come out on screen. It's just going to sit in the buffer. Okay, for 5 seconds, it's going to sit in the buffer until the C in line is encountered. When it enters the C in line, that's when it's going to print it out. Okay, so now if you run it, it'll basically, it's not UNISTD. Oh, it's not. Where is this file called sleep? Get rid of UNISTD. You just go to Google and find out. Google and say sleep. Sleep open as a C++ sleep. C++ sleep. Yeah. It'll tell you how to use the C+ sleep function. Some include file. I mean, UNISTD is what I used, and it worked for me. So on this computer, sleep function. Yeah, further down. Oh, it does say. It says you have to include a file. What does it say? It says unistd.h. Oh, I see. It has to unistd.h. Yeah, I think you forgot the .h. Okay, there you see, it's running, but nothing's happening for 5 seconds. And after 5 seconds, it says, what is your name? Yes? So this is a cool experiment. It's a cool experiment. And you can ask your friends too at some point and say, hey, you know what? I'm running this program and I'm asking what's your name, but it's waiting for 5 seconds before actually asking me. Why? Because for 5 seconds, it didn't flush the string. And after 5 seconds is when it encountered the CN, and the CN says, well, now you're expecting user input. I better flush everything that I need to tell the user before I ask them to tell something to us. Does that make sense? Okay, so does it answer everybody's questions? Now feel free to ask if you don't, because we only have to talk about branching statements next week. And I was thinking today that if very optimistically that maybe we finish everything, we'll do a little bit of branching today also, but we don't have to do that. Okay, so today we can just do input and output, but this is basically what's going on. Is everybody okay with this so far? Good, right? Now what we can do is, now that we have that program, so have you copied that program? Command A and copied it. Okay, now in the /temp directory, we are going to create a file called samir.cpp. Right? So, and the way we're going to create this file, let's not go into an editor or something. I'll do something very brain dead and simple. Okay, say cat space greater than, and then say samir.cpp. Okay, now when Samir hits enter, what the system is going to do is cat is a special program which will now, because it's not being told, given it, not giving arguments now, let's forget about it. So cat is a program that is going to read whatever is typed into the keyboard and stuff it into, whereas cat doesn't do it, right? That greater than sign is going to stuff everything you type into that samir.cpp file. However, don't type anything, paste it, right? Hit enter one more time, and now hit Control D. Okay, now we've created a file. In that directory, there's going to be a file called samir.cpp, which contains that file. How do you know? Do an ls space -l. ls, there you go. You see that file? Samir.cpp. That is a file. Along with the other files, you also see that file. Now you want to see what's in that file? You just say cat space samir.cpp. It'll just dump the contents of the file right on the into the terminal, right? There you go. That's what's in the file. And this is what you copied and pasted. Yes?
Yeah.
Okay. Now what we're going to do is try and compile this file exactly the same way that those guys are doing it, right? On that side, online GDB, they're compiling this file and running it. We're going to compile a file and run it by hand, right? This is bare bones. We're getting right to the bare bones. We're going to compile and run this file by hand. And the way to compile this file and run it is basically type in this command, G++, and G++ is a C++ compiler written by GNU, right? So it's a free C++ compiler. Let's make sure it actually exists. Hit enter and we'll see what it says. No, G++ and hit enter. Okay, it does exist. Why is it not coming back to you? Hit enter a couple times. Wow, that is so strange. Why is it not? Oh, it was just very slow. G++ hit enter one more time. Okay. All right. It wasn't waiting for input. It was just locating a file. You probably have lots and lots of stuff on your computer and it was trying to find that file. Okay. So, all right. G++ is our compiler. What we want to do is tell G++, invoke the program, right? And say, dear G++, I want you to run, take this file called samir.cpp, translate that into machine code, ones and zeros that I can't understand anymore, and produce another file called Samir, not CPP anymore, just Samir. Right? That Samir file can now be executed by me. Okay, that's what we want to do. And the command to do that is G++, G++ space -o, right? That is the output file. The name of the output file you're going to produce is Samir, S-A-M-I-R. You can call it anything you want, really. If you don't give it a name, it'll just produce a default name like a.out or something like that. So we would give, right? Now space. Now we want to give it the file that it should compile. And that file is samir.cpp. And don't type it in. You can actually hit tab. Hit tab, it'll complete for you. No, S and then tab. S and then tab. Okay, so this has got to be unambiguous. Otherwise, it'll tell you all possible completions. Now, if Samir hits enter, it will create another file. This G++ will create another file by reading samir.cpp. It'll read it, convert it to machine code, write the machine code into a file called Samir. Right? There you go. There's that file, Samir. Right? Now, if you look inside Samir, if you want to look inside of Samir, you say cat Samir, it's going to print a whole lot of gobbledygook on your screen, right? Right? That's all junk. And all of that is all binary instructions in ones and zeros. That's why you can't read it. But a computer can read it, right? The CPU can understand that program, but a human can only understand Samir.cpp. Does that make sense? G++ is a program called the compiler that took Samir.cpp, which humans can read, and translated that into another file called Samir, which humans can't read anymore, but the CPU can read.
Is this one step still removed from binary? Like, why does it have like so many letters, special characters, and stuff like that? Like,
no. Oh, I see. Yeah. Okay. So yes, the actual executable code is in there, but it has also put in a lot of meta information in that file, because what happens is that today modern programs, when you compile and run modern programs, it's not, your code is not the only thing that you expect to run. You expect to run a lot of library code too, right? Cout is a library, Cout is a library object, and eventually you're going to be writing lots and lots of programs which will use stuff in libraries. So what the computer actually does when you build a program like Samir is saying, well, this is the program that needs to be run, but it also uses Cout, it uses this, it uses that, uses that. So one way to make this a self-contained program to run is I'll take everything that, everything the program needs to run and put it all inside this one package. And it could produce a file, right? It could do that. If it did that, you won't see all that. However, the CPU, the compiler is actually intelligent and said, there's going to be millions of programs that use Cout. Millions of programs that use all these resources. Now, if I bundle all these resources into all of those programs, every program is going to be like big. So what I'll do instead is, because these resources are common in the system, they're called dynamic libraries, okay? And they only need to be used when the program is running. I'll have Samir's code in machine code, right? Whereas these other things, I'll just put pointers saying, well, he's using a basic string, he's using Cout, he's using these things, and these things can be found there. So there's all that meta information. So your program contains your code plus meta information. That's what you're seeing there. Does it make sense?
Yeah. So
your program is actually in there.
Should you be able to see the binary here then?
Yes, you can see the binary of your program, but you won't be able to understand it, right? Unless you are, you look at the binary instructions and map it back to assembler instructions. Your instructions are in there. The way to actually see your binary instructions, by the way, if you're really interested, go to the command line, hit Control L, right? Control L to go to the top. Now, the way to see the binary instructions in your program is type OD, right? OD space dash, let's say dash X for hexadecimal, dash X, right? Space Samir, S-A-M-I-R, right? And those are the instructions. Those are the binary instructions in hexadecimal, right? Obviously, it's not giving to you in ones and zeros. It's giving, and not only, it's not only your program, of course, there's all this meta information also in there, but your program is in there towards the end of that thing all those numbers are basically your program translated into code. Now I'll show you one step, what you said, right? One step removed from binary. It's actually many steps removed from binary. I'll show you one more thing. So go back to, Control L one more time. All right, now Control L, right? Now up arrow until you get the G++ line. Right, now where you say -O Samir, get rid of the -O Samir and say dash capital P. I've forgotten, we're going to try it out. Capital P, right? Space Samir.cpp. I think that's what it is. Because -P says pre-process the file by making all the includes, but don't compile it all the way to machine code yet. So I want to see what the output is. Oh, it didn't do that? Yeah, here's what you should do, right? Now, instead of G++ -P, do CPP Samir.cpp. It's called the C preprocessor. And no -P, no -P. Yeah, hit return. There you go. Okay, now, so now up arrow. No, we don't have to do that. Up arrow, and then put a vertical bar. I think shift something, right? Vertical bar, right? Now type less. Type less. What this does is exactly the same thing as what he did before, but less is something that paginates things, meaning there's a whole lot of stuff. I'm going to show you one page at a time. You had to hit spacebar to go from one page to the other. That's all it does. Okay, that's what less does. Now, so there you go. That is Samir's file. Now it's gone through what is called a preprocessor. If you go right to the end of this file, you'll actually see Samir's program. You go to the end of the file by hitting greater than sign, right? Go hit greater than. There you go, right? That is the very end of the file, right? And that's Samir's program. But that's not what the compiler sees. The compiler sees this whole thing, right? The whole thing is what the compiler sees. You go right to the top, less than, right? Less than sign will take you to the top. Right now, all pages, space bar, all the pages, right? Space, all of that is given to the compiler. Okay, so Samir only wrote a 3-line program, and he thinks, well, I'm going to get the compiler to look at my 3-line program and compile it. But the compiler says, oh, here's a program that Samir wrote, and it's like 50,000 lines long because it's already included all those other files. Does that make sense? So this is what the compiler is going to turn into machine code, and all that junk you saw up there will get turned into metadata that will get stuffed in front of the machine code. Yeah, is that okay?
How do I get out of this?
Oh, Q. All right, Q.
I have a question.
Yeah.
So 90% of the binary is just changing the include into machine code.
90% of the binary is changing what into machine code?
The include.
In this case, because the program is really small.
Yeah. So can you change from binary to C++ code or any other code?
No. So what you just described is called reverse engineering. Once you go to binary, it's very hard. It's possible, right? I mean, there are people in, if you go to the NSA, DARPA, China, Russia, all these intelligence agencies, or even hackers out there trying to figure out how someone else's program works, they can decompile it. It's called decompilation. Compilation is going to machine code. Decompilation is taking the compiled code and trying to figure out, you can't tell anymore. You're trying to figure out what resulted in the machine code. That's what you're asking, Cecilio. Is that what you're asking?
Yes.
Really, really hard. And that is why compiled code is a whole lot more, safe for many people who want to protect their intellectual property and shit like that. Okay, because people can't tell immediately how you're doing stuff by looking at your code once it's been translated to binary. Whereas if it was a Python program or even a Java program, as bytecode is easier, right? Python or PHP, you put it out there, your logic is out there. Everybody can see exactly what you're doing. Yes?
I see, yeah.
But C++ takes all the way to be machine code. But even then, that should not be the motive for using compilation, right? When people say I'm compiling it because I want to keep all the secret, they're not going to succeed in a big way. Okay, you should never rely on patents and stuff being secret in order to succeed in life. That's the difference between jealousy and envy, right? If you keep secrets and saying, well, I want to succeed, but those guys shouldn't succeed, that's jealous, right? But if you say, it's out there, everybody can do it, but I'm doing it in a better way, that's better, I think. So don't Yeah. So the point for the reason to compile code is not to obfuscate or keep your secrets from other people, but it is really for making your program faster. Yeah, that's the only reason you should do it.
Okay.
All right, now let's run the program right here, right? That Samir created. You'll have exactly the same behavior as there. So you say /Samir, okay, /Samir and hit enter, and it'll just do exactly the same thing, right? You can type in your name and type. There you go. So now you know, right? Now you have actually been in a position, well, not been in a position, you have actually created a file. Hopefully every one of you has also done it or will be doing it very soon. Remember, Samir did it on screen, but every one of you has to do it on your computer. You can't say, well, I saw Samir do it, I know how to do it. I can tell you, every single time I've done this in the past, every single time. And you know, I'm like over 50 years old now, but every single time I've written a program or even a math proof, and I read someone else's proof or saw someone else doing the proof and said, yeah, okay, that's how you did it. Oh yeah, cool, no problem, I understand it. I've done that millions of times before math exams. Okay, I go to a math exam in the past when I was a student like you, and just before the exam, one of the students tells me, "Hey, did you master Cauchy, the Cauchy Riemann? You know, some proof like that. Okay, did you do that? Because that's very important. I heard from the professor that that's really important. It's going to be tested." I said, "Well, I don't know how to do that." And he says, "No, I studied. Fortunately, I can show you how to do it." Okay, and they show it to me. Now I look at the proof and say, oh, thank you, man, I now totally understand that. And I go in and predictably, I see that question in the exam. And I say, I know how to do that. Thank goodness I talked to, this person before and they taught me how to do it. And I say, do it, I get stuck, okay? And I can't figure out the answer until the end of the exam. It's happened to me so many times. So that is why I say, and programs are not like exactly like that, okay? So you can see someone else writing the program and you can think that, yeah, well, that's how it works, okay? And you think that I can do it too. But when you try and do it, you'll find you'll get stuck. You try and do it, and if you don't get stuck, let me know, all right? So, or if you do get stuck, at least also let me know so I get a sense of statistics and be able to tell future students too. But programming is something that you will only learn by doing, not by watching someone else, right? If you go to the Y, enroll in swimming classes, and they say, well, you're not going to watch 50,000 people swim, okay? All right, now you've seen a lot of people swim in different ways. Now you jump into the water, in the deep end and swim, right? You're dead right there. Okay, so you got to swim on your own, and you can't assume that I've seen how it's done, I know how it's done. No, you've seen how it's done, you don't know how it's done. But if you do how it's done, you know how it's done. Does that make sense? Now we've created a program and also compiled it by hand and run it, which is exactly what Online GDB did in the back end, which is exactly what Xcode and VS Code and all these other IDEs you're going to use in the future, right? In a couple of classes, you're going to be using IDEs. That's what they're going to do. Now, we've done that right off the bat. In the second week, we've actually done what all your IDEs are going to do. So from now on, when we use IDEs, you know what's going on in the background. Okay, so the IDEs are not doing magic stuff. So you go to a browser and do things, oh, it works there, but I can't have a program that I can show to my mom and dad, on your phone or on your computer. No, now you know how to do it. So you can actually produce a program on your Mac and it'll run too. Okay, so everybody okay so far? Now we can go back to the program and start embellishing it with more.
I have another question.
Yeah, go ahead.
Would any of this be any different if you're doing it on Windows, since this is on Mac?
Yeah, good question. Okay, so on Windows, I believe that you have to install G++, okay? You have to install G++. There is a package called, I think there is Windows, are you talking Windows 11 or Windows 10?
Windows 10.
Okay, I think that Windows 11 comes with a Linux terminal, a Linux-like terminal. There is a terminal off the, because previous Windows, you got to install Cygwin or something like that to give you a Linux terminal like this. But I think the later versions of Windows come with a terminal like this, and you should be able to do it. But in a previous version of Windows, you got to install something called Cygwin. Well, I haven't used it in a long time, so maybe things have changed, but you can Google, right? Okay. Cygwin, Cygwin, Okay, CYGWIN. And if people find out there's a better way to do this on Windows, please share this on the forums, okay, on Reddit, so other people can trade. So SIGWIN gives you an environment just like this on Windows. Otherwise, you can't. Right.
Thank you.
Otherwise, what you can do is install the Microsoft compiler. I think it's called CL or something like that, right?
Yeah.
And then you have to invoke the compiler with the full path. It's not in your path by default. You got to say, and
then add it to path. Yes.
Yeah, it's a bit of a pain. And
Mm-hmm.
on Linux and Mac like systems, it's just there by default.
I see. Thank you.
All right. Unless you have any other questions, anybody else, we'll just go on to that program and try and embellish it, do some cool stuff. Or do you guys want to play? What time is it now? All right, 9:26. How about 5 minutes, 5 to 10 minutes? If you don't have to do it, right? We can go on to the next step right away if you want. But if you want 5 minutes, just play around with this, do more embellishments of your own. Maybe not Samir. Someone else tell Samir, hey, let's try this and change the code and try it out. You just have to keep on experimenting, right? Maybe 50%, 90% of your stuff doesn't work. Fine. You want lots of stuff to not work, right? When we're learning, we want lots and lots of things to break and not work. Okay. If things keep working all the time when you're learning, we're not learning anything. We have to be in a place at the fringe where you can meet a grizzly bear anytime. Otherwise, you're not exploring new territory, right? You're still, safe in your home. You got to go out there like Lewis and Clark. Okay, out there saying, oh, I'm at the territory. I don't know what's going on. There's, wild forest out there. We could get killed anytime. Oh, we got mauled a few times. Okay, that's when you're learning and conquering new territory. So please go ahead, make lots and lots of mistakes. Try things that are not going to work. But if you want to do a few more things here and then give it to you, I'm happy to do that too. Why don't we do one more thing? Okay, let's try and do this. Okay, this is the thing I have in mind now, because when I was talking, I embellished that original idea a little bit more. So what we're going to do is generate a random number. Okay, between, I don't know, let's generate a random number between let me look at your faces. All right, between 15 and 25. Okay, assuming you're all aged between 15 and 25. All right, 15 and 30. All right, so we're going to generate a number between 15 and 30, which we'll assume to be your random age. Okay, random age. Now, after you've got that number, you're going to ask the user, saying, "What is your age?" And obviously, it's you ask the name and then ask their age also. People don't have to type in their real age; they type in another age, and then it's going to respond by saying, "Hello, Andrew. Nice to meet you. You're 79 years old." But I'm only 15 years old, or something like that. Or it could say, "Oh, we're both odd. You're an odd age, and I'm an odd age too. Or you're an even age, I'm an even age too." So you could say we're both even, or you were both odd. We can say something like that. How about that? Is that a reasonable thing? Would you like to try that? Because when we do that, I'll also introduce one more thing. Okay, one more thing, which is an arithmetic operator. Okay, and it's an operator that during the early stages, most people don't get an opportunity to use. So we'll use an operator, and we'll also get a chance to venture into what we're going to do next week, which is branching statements, right? Making a decision based on the value of a variable and saying, if the variable is this, I'm going to do that. If the variable is that, I'm going to do this, right? Two possibilities based on what the user says. How about that? Is that a cool thing? Okay, so here's what we're going to do, right? So after the see out, what's your name, and reading, right? So hello, right? That's great. Now, after the second see out, hit enter. And one more enter, because it's going to be a new paragraph now. Now we're going to ask the user for their age, right? So you say, and yeah, so you can say CN, and then what is. Okay, all right. Now we change the C into a C out, and the operator should be changed to, it's a left shift, right? A C out, left shift. No. That C in that you type should be a C out, and it should be a left shift, not a right shift, because going out to the console is left shift. Right now, you're going to C in into a numeric variable, okay, which means you don't have the variable anymore. You're going to go up to the top and create a new variable called int age, okay, int their age. we call it int space their age. You're going to have your age too. So int their age, and then comma after the their age, and say our age also. You have two variables up there, int their age, comma our age. Yeah, you can do it that way, or you can put both of them on the same line. That's also possible. You can put both of them on the same line, saying int their age, comma our age. That's also possible. And the way that he's done it also, oh, he changed it. Okay, so right, so both of them are okay. Now you're going to read what the user says into their age. Now, one thing we can do, a nicety, right? These are programming niceties. Since we already know their name, when you say, what is your age? You can actually say that in a much nicer way by saying, hello, Andrew, what is your age? Right? You can say, hello, Andrew, what is your age? Instead of what is your age? So how would you say that? No, not there. So you want to say that before. So you want to say hello, and then username, and then what is your age? So let's reformat it. So after the Cout and the left shift, you're going to say hello. Right after the first, no, right there. Yeah, Cout.
This one.
Yeah, change the what is your age into hello. Change what is your age into hello.
Yeah.
Oh, I see. You got that up there. We'll get rid of that. We'll get rid of the previous Cout. Get rid of the previous Cout altogether.
This one.
Yeah, get rid of it. Okay, now you can say, yeah, get rid of that thing and say hello. And then no question mark there, and space though, space. Right? And then close the quote. Now you can do another left shift. You're going to chain together more, right? Now you can say username. And then another left shift. Now you're going to say a comma, right? Hello, Andrew, comma, right? Yeah, great. What is your name? And then what is your age? Question mark. Okay, and space after the question mark. Okay, now you're going to read in their age. Now on the next line, we're going to decide what our own age is. Okay, so one more blank line, and say put a comment there. Put a comment saying select a random age for ourselves. Select a random age for ourselves. Okay, and here is what we're going to do. On the next line, we say our underscore age equals, right? Sorry, rand open close. Okay, that is a library function. It's already given to you. It's out there. We can use it. Rand will give you a number, totally random number. Okay, and it's going to be a huge number. We don't want the huge number. What we want to do is take that huge number and clip it to a small range. So what we're going to do is we're going to assume that your ages start at 15, right, and go up to 30. So what we want is basically a number between 0 and 15 that you're going to add to a 15. So 15 plus 0 is going to be 15, and 15 plus 15 is going to give you 30. So what we're going to do is, so the way to do this is different in different languages, right? So the way to do this is going to say rand and then space. Yeah, no, not there. Outside of the parentheses, you say space, percent sign. Yeah, space 15, and then space plus 15. Okay, now I'll put a comment above that. We'll put a comment explaining what it is so that people can understand that. What the following statement does is generate a random number using rand and divide it by 15 and take the remainder. Divide by 15 and take only the remainder, right? You can and take the remainder. Yeah, and take the remainder only, right? And then within parentheses, you can say that the percent sign is the modulus operator that does it for us. Percent sign is a modulus operator, does it for us. Yeah, okay. And add that to 15, and add that value to 15 to give us a number in the range of 15 to 30. so far is that, so we did some, small bit of logic there, okay, a very mini dance, a micro dance there, but this is exactly what you're going to do, right? In your career as a programmer, you're basically just going to do lots and lots of stuff like that, slightly, more and more sophisticated ways, but exactly that. It's just logic. We're just embodying logic in our code there. All right. So is everybody okay with this? That's our age. That's how we calculate an age between 15 and 30. Yeah. Okay. So after that, on the next line, yeah. So one more blank line out there. You can say one more blank line, and you can say, so we're going to say, put a comment there saying, determine if we're both odd or both even. Oh, in fact, no. So let's not do that. We'll say, no, we'll just say, we'll just, here's the thing we're going to do. We're going to write the comment after we write the code. Okay, we'll write the code. We'll tell us what we're going to do, and then put the comment above that saying this is what the code does. Okay, so let's write the code. Okay, so what we're going to do there is say hello. Oh, you've done that already. What is your age? You've got that. You can say hi. See out. Left shift hi. With hi within quotes. Hi within quotes. And then the same thing as you did before. Hi username and all. Hi username and a comma. And then instead of what is your age, we'll do something else. Right. Right. And then semicolon right there. Go to the next line. Right. On the next line, you're going to say if within parentheses, you're going to say their age space, their age space %2. Okay, %2 space equals double equals 1. Okay, what does that mean? Well, actually, we make it double equals 0. That's easier. Double equals 0. Okay, what does that mean? Percent is an operator, a modulus operator that divides a number and gives you the remainder. So we're saying divide a number by 2, and is the remainder 0? That's a question that's asking. All right, that if statement is asking a question. Take their age, divide by 2, is the remainder equal to 0? What is that question asking?
If it's even or odd.
Yes, it's even or odd, right? Because if you divide a number by 2 and it's the remainder is 0, it's an even number, isn't it? So you're going to say if the remainder is 0, you're going to say C out, left shift. You can say you're even. Yeah, and then you can do a slash in there or something like that. Slash in. Right, and then after the closing brace, hit enter. You say else, open brace again, and you say C out, you're odd. There's no other possibilities, right? You either have to be 0, even or odd. Yeah. The funny thing is in math, many students think, oh, even and odd, only 2 possibilities for numbers, just like positive and negative, only 2 possibilities for numbers, right? But actually that's not true, right? Because numbers have 3 kinds, positive and negative, and 1 more. Okay, but parity only has 2 kinds, even or odd. Well, what are the 3 kinds of non-parity classes and numbers? You have positive numbers, negative numbers, and a number that is neither positive or negative. What is that?
0.
0, right? That is why later on when you do sorting and things like that, you say non-negative, not positive or negative. You say non-negative, that covers the whole thing. And likewise, when you do sorting, you don't say descending order or ascending order. You say non-ascending order or non-descending order, because successive elements can be equal to each other. Okay, all right. So and slash your odd, slash, and you need an ANDL or slash n after that. Okay, all right. Now you can do the same thing for your age too, right? A blank line after that, and then say if my age %2 is, oh, you changed that, or no, you were changing the wrong thing. The first one is their age, and then the second one should be our age. That's why if you put a blank line, put a blank line between the two ifs. Yeah, the second if should start. Yeah, there you go. That'll be easier.
This should be our age.
Our we are. I am even, and I am odd. Okay, that's it. That's it. Now this program. Well, we need a comment. Okay. In fact, put a comment about the first if statement saying, well, let's do some stuff with the, put some stuff. Yeah, let's do some basic stuff with the ages. Yeah, messing around. Okay. All right. Now, if you run this, you'll actually see what we had in mind. Every time we have to run it and make sure that it's exactly the same as what we have in our mind. Right. So, yeah. Okay. All right. So 14. There you go. You're even and I'm. You're even and I'm even. Oh, you didn't actually tell what your age was, right? In fact, you can say I'm even, and then say my age is, right? After that thing, you can put it anywhere you want. But I'm not going to do it. You guys can do it, right? Because you need to have some fun stuff to do too. There's about 10 minutes left in class. How about you guys take this program and make changes to it. Some changes won't work. Some changes will work. Hopefully, Samir will be here to. Samir, you're happy to coordinate this for the rest of the class? Meaning that they'll say something and you can type it in and say, hey, I tried that. It didn't work. You want to try something else? And so
Yeah,
on.
I just have to leave at 9:50.
Yeah, everybody will leave at 9:50, I think. All right. So everybody okay with this so far? I think we covered a lot of important and interesting stuff here. And remember, from next class onwards, we're just starting to ramp up, okay? So we've done this, branching statements. After that, we're going to do looping, right? Next week, we'll do looping. And after that, we'll start talking about arrays, okay? Arrays and vectors. And then soon after that, we're going to talk about functions, okay? Functions, methods, classes, lots and lots of exciting stuff. And when I say exciting, it's not that exciting means it gives you a lot of possibilities, right? Lots of possibilities for you to play around. If you go to a playground and there's only a few toys there, you're gonna say, oh, it's boring. Yes. But here you will be led into a playground. There's so many possibilities, so many things which you'll learn in CS2A, which means that when you go into CS2B, you are literally entering an area where there's so many things to do. Play around and get creative, right? That's why it's so important to pay a lot of attention in CS2A and get solid on these concepts. Okay, just keep on playing. Got to keep on playing and get utterly familiar with all these tools. Okay, everybody okay with this? Samir is going to help, and you guys should call out the code. Samir will type. Okay, and I'm not going to be in front of your face. I'll turn the laptop around to face a yard, and I'll be out here. I'll be listening to you guys. No silence. Okay, please, no silence. Keep talking, and keep coding. Okay, and hopefully Samir is not going to be doing everything on his own. You guys are going to tell Samir, hey, Samir, I want to try this. Can we do this? Can we do this? Right? Take turns and just tag each other and play with this. Okay. And if you're ever stuck irretrievably, just call me. Okay. I'm just going to be here. Maybe I'll go make a cup of coffee or something. But I'll be within earshot. Okay. Is that okay? Is everybody happy so far? Did you guys learn something useful today? That's the important thing. At the end of the day, if you didn't learn anything useful today, there's no point in this class. Yes. Was this useful?
Definitely learn stuff.
Thank you. Right. If not, you should always just let me know. Right. Just let me know. We can proceed at any pace. Right. We can proceed at any pace you want. It needs to be the right pace for you. And I don't know, you know. So you guys have to tell me. Keep on telling me. Slow, fast, everything. Okay with me. Right. So go ahead, play as much as you want. I want to hear squeals of joy. Okay. When you're little kids in the playground, you just sit on the bench and you hear the squeals of joy. It's so much fun. Okay. That's what I want to hear.
Hi. How do you make a Boolean?
Oh yeah, also, why is there a random in the hour age? Is that variable?
That's a library function. It just gives you a number from like 0 to 32,000 or something.
Why then?
What? Oh, because we use that to seed a random number from 15 to 30.
Oh, wait, isn't our age just your age plus my age?
No, it's not. You think of it like our age as in our class, like we're the other side of this. You know, the user is talking to us. That's their age, and our age is what we're comparing to.
Oh, I see. So it's just a random age. Got it.
Ooh, that is actually a very good point. What is the range of Rand?
And
think-
yeah, I think it's. I'll look it up, but I think it's like 32,000 some power of 2.
Okay.
It's
Very
Oh,
big.
it is. It is from.
yeah.
So it is from the first number and the second number, I think.
So it's from 0 to 32,767.
Oh,
You could like, I'm pretty sure you could set the range to
Yeah.
a certain like,
well, yeah,
value
but I'm saying
anyways.
like if you just had the Rand function, what is the range of that just by default?
Yeah, 0 to 32,000.
Which is good to know.
So this is from 15 to 30. So it's from the second number, so after the plus, and then to how many number is in the first one. So it's like from 15 plus to 15 plus 30. No, 15 plus 15. Because if you change that to maybe 150, so maybe 15 plus 100, it will be 100 to 115. Yeah, random.
Do you need to include something for Rand to work?
Is it inclusive?
Oh, minus.
I don't think you have to include anything. I think it's just part of STD.
All right.
Do you guys know if Rand is inclusive? So that means it can pick 100 and 115, or is it between 100 and 115?
Oh, what do you mean? Oh, I see. I think it includes it. So if it's 150.
think what
So yeah,
helps
so in
is-
the current code, I think it can produce 15 and it can also produce 30.
You just have to
That's a
adjust
possibility.
parameters depending on what you want. So the best way to think of the percentage sign is to, like, you get a number from 0 to 32,000, right? And then you keep subtracting 15 until you end up with a number that's less than 15. So that way we can generate a number that's, you know, from 0 to 15, right? And that's the range we have. We want from 15 to 30, which means there's 15 numbers we're generating. And then since it's always going to start out at 0 and go up to the range, then we have to increase it by 15.
So if I deleted plus 15, it would just make the range 0 to 15?
Yeah.
Well, 0 to 14.
Or okay.
Another good question to think about is when you're doing the modular 15, is the range going to be 15 to 30 or 15 to 29?
29.
That's one of
Yeah.
That's one of those edge cases you might have to think about sometimes. Since here you might think that you'll get 30, but in reality, if it's 15 modulus 15, there's no remainder, so you get 0. So you're only going to be able to go up to 29.
I looked it up in Stack Overflow. It said that if you only, so like if it's only one number, for example, like a percentage sign and then 100, it will only go from 0 to 99. But if you do it like with the plus, it will also include the 30 here.
Yeah, so an easy way to make it 0 to 30 would just be to +1 or set it to 16 as well.
Yeah, so 30 plus 1. Like, actually, with 0, I mean 30 plus 0, I guess.
All right, I have to hop off. I'll post the code from class today on the Reddit for people to like look at when I get a chance. See y'all.
Okay.
Thank you, Samir.
Awesome. Thanks. I gotta go too. Bye.
Alrighty.
All right.
Bye, everybody.
Bye-bye.
All right. Thank you all. Okay. I'm going to see you on Tuesday. Please code. Okay. All
See you
over
on
the
Tuesday.
weekend. You have to keep coding. And it'll be fun. It'll be so much fun. I can guarantee, right? It'll be so much fun. Thank you.
It's gonna be amazing.
All right. I'll see you on
Bye now.
Tuesday. Have a good weekend.
Bye.
Bye.
Walter,